Hello and welcome back to AI Explains Everything, the video series where we use artificial intelligence to explain complex concepts. In this episode, we'll be diving deeper into machine learning, one of the most important components of artificial intelligence. So, what is machine learning? At its core, machine learning is a type of artificial intelligence that allows a computer to learn from data without being explicitly programmed. Machine learning is used for a wide range of tasks, from image and speech recognition to natural language processing and predictive analytics. There are many different types of machine learning algorithms, but they can generally be grouped into three main categories: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is a type of machine learning where the algorithm is trained on a labeled dataset. A labeled dataset is one where each data point is assigned a label or output value. The goal of supervised learning is to learn a function that maps input data to output data, given the labeled examples in the training dataset. The process of supervised learning begins with the collection of data. The data is then split into two sets: the training set and the testing set. The training set is used to train the machine learning algorithm, and the testing set is used to evaluate the performance of the algorithm. Let's take the example of training a machine learning algorithm to recognize dogs in pictures. The first step is to collect a large dataset of images of dogs and label each image as a dog. The labeled dataset is then split into the training set and the testing set. The training set is used to train the machine learning algorithm to recognize dogs in images, and the testing set is used to evaluate the performance of the algorithm. The machine learning algorithm is typically a mathematical model that takes the input data, in this case, an image, and produces an output, in this case, a binary classification of whether the image contains a dog or not. The goal of the algorithm is to learn a function that maps the input data to the output data, given the labeled examples in the training set. One popular algorithm used for supervised learning is the neural network. Neural networks are modeled after the structure of the human brain and are designed to learn complex patterns in the data. A neural network consists of layers of interconnected nodes, each of which performs a mathematical operation on the input data. The output of each node is then passed to the next layer of nodes until the final output is produced. The process of training a neural network involves iteratively adjusting the weights and biases of the nodes to minimize the difference between the predicted output and the actual output. This process is called backpropagation, and it involves propagating the error from the output layer back through the network to adjust the weights and biases of the nodes. One important aspect of supervised learning is the choice of loss function. The loss function is a measure of how well the algorithm is performing on the training data. The goal of the training process is to minimize the value of the loss function. There are many different types of loss functions, but some common ones include mean squared error, cross entropy, and hinge loss. Another important consideration in supervised learning is overfitting. Overfitting occurs when the machine learning algorithm becomes too complex and starts to fit the noise in the training data, rather than the underlying pattern. This can lead to poor performance on the testing data. To prevent overfitting, techniques like regularization and early stopping can be used. In conclusion, supervised learning is a powerful tool in machine learning that allows algorithms to learn from labeled data. The training process involves iteratively adjusting the weights and biases of the nodes to minimize the difference between the predicted output and the actual output. Popular algorithms used for supervised learning include neural networks, and the choice of loss function and the prevention of overfitting are important considerations in the training process. Unsupervised learning is a type of machine learning where the computer is trained on unlabeled data. This means that the data does not come with any predefined labels or categories, and the computer must find patterns and structure within the data on its own. Unsupervised learning is used in a variety of applications, such as data mining, clustering, and anomaly detection. Clustering is a common application of unsupervised learning. The goal of clustering is to group similar items together based on their characteristics. For example, a company may want to group customers together based on their purchasing habits to better understand their behavior and target them with specific marketing campaigns. In this case, the company would use unsupervised learning to find patterns in the purchasing data and group customers with similar buying habits together. One popular algorithm for unsupervised learning is K-means clustering. K-means clustering is an iterative algorithm that works by assigning data points to clusters based on their distance from a set of cluster centers. The algorithm starts by randomly selecting k cluster centers, where k is the number of clusters desired. Each data point is then assigned to the nearest cluster center, and the cluster centers are updated to the mean of the data points assigned to each cluster. This process is repeated until the cluster centers no longer change, or until a maximum number of iterations is reached. Another common application of unsupervised learning is anomaly detection. Anomaly detection is the process of identifying data points that are significantly different from the rest of the data. This can be useful in many domains, such as fraud detection in finance or fault detection in manufacturing. Unsupervised learning can be used to identify anomalies by first learning the normal patterns within the data and then flagging any data points that deviate significantly from those patterns. One popular algorithm for anomaly detection is the isolation forest algorithm. The isolation forest algorithm works by recursively partitioning the data into subsets until each subset contains only one data point. Anomalies are then identified as data points that require fewer partitions to isolate them from the rest of the data. Unsupervised learning can also be used for dimensionality reduction, which is the process of reducing the number of features or variables in a dataset. This can be useful in many applications, such as image processing or text analysis, where the data may have a large number of dimensions or features. Unsupervised learning can be used to identify the most important features or dimensions and reduce the dataset to a smaller set of features. One popular algorithm for dimensionality reduction is principal component analysis, PCA. PCA works by finding the directions of maximum variance in the data and projecting the data onto these directions. The resulting projections, or principal components, can be used as a reduced representation of the data. In conclusion, unsupervised learning is a powerful tool in the field of artificial intelligence. It allows computers to find patterns and structure within data without the need for predefined labels or categories. Applications of unsupervised learning include clustering, anomaly detection, and dimensionality reduction, among others. With the increasing availability of large datasets and the development of more advanced algorithms, unsupervised learning is sure to continue to play a key role in the field of AI. Reinforcement learning, RL, is a subfield of artificial intelligence, AI, that involves training a computer or machine to make decisions and take actions in an environment to maximize a reward. It is based on the idea of learning through trial and error, where the machine learns by interacting with its environment and receiving feedback in the form of rewards or penalties. RL has gained popularity in recent years due to its applications in various fields such as robotics, game playing, and autonomous vehicles. It has been used to create self-driving cars, robots that can perform complex tasks, and intelligent game-playing agents that can beat human experts. At the heart of RL is the concept of an agent, which is a program or machine that interacts with its environment. The environment can be anything from a simple game board to a complex physical environment like a factory or a city. The agent takes actions in the environment and receives feedback in the form of rewards or penalties, depending on whether the action was beneficial or detrimental to its goal. The goal of the agent is to maximize its cumulative reward over time. This means that the agent must not only focus on immediate rewards but also consider long-term consequences. For example, in a game like chess, the agent may need to sacrifice a piece in the short term to gain an advantage in the long term. The RL process can be broken down into three main components: the agent, the environment, and the reward signal. The agent is the program or machine that interacts with the environment, while the environment is the context or situation in which the agent operates. The reward signal is the feedback that the agent receives from the environment, which tells it whether its actions are good or bad. The process of RL starts with the agent taking an action in the environment. The environment then responds with a reward signal, which reflects the quality of the action taken by the agent. The agent then uses this feedback to update its strategy or policy, which is the set of rules that determine its actions. This process is repeated many times, with the agent taking different actions and receiving different rewards until it has learned to take the best possible actions in the environment. One of the main advantages of RL is its ability to handle complex and dynamic environments. Unlike supervised learning, where the machine is trained on labeled data, RL can learn from its own experience and adapt to changes in the environment. This makes it well suited for tasks like game playing, where the environment is constantly changing and the agent must be able to make quick and effective decisions. RL algorithms can be divided into two main categories: value-based and policy-based methods. Value-based methods involve learning a value function, which estimates the value of each state or action in the environment. The agent then selects the action with the highest value. Policy-based methods, on the other hand, learn a policy directly, which maps states to actions. The agent then follows the policy to select its actions. RL has several challenges and limitations that must be addressed to make it more effective. One of the biggest challenges is the exploration-exploitation dilemma, which refers to the trade-off between trying new actions to learn more about the environment and sticking to known actions to maximize rewards. Another challenge is the problem of credit assignment, which refers to the difficulty of assigning credit to actions that contributed to a reward. In conclusion, reinforcement learning is a powerful and flexible approach to artificial intelligence that has the potential to revolutionize many fields. By allowing machines to learn through trial and error, RL enables them to make decisions and take actions in complex and dynamic environments. While it has several challenges and limitations, ongoing research and development are making RL more effective and useful for real-world applications. And that's it for our overview of machine learning. We've discussed the three main categories of machine learning, as well as some of the different models that can be used within each category. In the next episode of AI Explains Everything, we'll be discussing neural networks, one of the most powerful machine learning models out there. Thanks for watching, and we'll see you next time.